Lab 8 exercise here. So you can download the data from this data file, which I've done here. I called the data Lab 8. And perhaps it's nice to see what the data looks like after you've downloaded it. So here I already have stacked data. However, my first column, the column called X, is not a useful column for me. So I am going to extract just the columns 2, 3, and 4. So I'm going to extract columns 2 through 4 and make that a new data frame. So when I look at that data frame, I now no longer have this first column, leading column of 1, 2, 3, 4, 5. Okay, some other things that you could do if you have this raw data in stacked form, you could use the xtab command to basically put out the same table as you've got here. And if you would like to know what the names of the columns were, one thing you could do, of course, is just rerun your data frame and look at what the names are. Or you could actually use the command called names of your data frame, which tells you what the names are. Okay, when my question is asking here to use some amount of digits, I think that a good idea is to switch how many digits you get in R. So here I'm just going to give more digits in R by saying options digits equal 9. And then I can run the two-way ANOVA by indicating that my data is from the data frame that I called df. And then here the first variable should be the numbers or the values, and then tilde either of the two columns. Now you probably, you could do bank type and the plus location, or you could do location plus bank type. I've done location plus bank type. I've done that order simply because I wanted to have the rows, which were the locations first, and then the columns. So because the locations were the rows and I wanted to have that first, I put locations first in my ANOVA code. And then I can actually see my two-way ANOVA results when I print the summary of my ANOVA. Okay, so that gives me the ANOVA table, which of course I've just filled in to WebWork here below. Again, remember that for a two-way ANOVA table, there is actually two different hypothesis tests. Okay, so you can see that there's two test statistics here. The F equals 2.1 and the F equals 3.3. So you need to be careful about which hypothesis you're talking about. In this particular question, it says when considering the rows segment. So it's just talking about this row here. So when it's talking about what is the hypothesis for this test. And for ANOVA, the null hypothesis is that the means are all equal. And another way of saying that is if the means are all equal, then there's no significant difference, meaning there's nothing special happening there. So the null hypothesis is that there is no change, or in other words, there is no effect or no significant difference. And the alternative is that there is at least one difference in average if you're going through. In this particular case, again, just continuing with this first row of the ANOVA table, it asks us to give the p-value as a probability statement here. So putting this all together, this is an F distribution, as you can see, certainly labeled on the ANOVA table that, with this capital F. And so this distribution is F. Its numerator degrees of freedom is 2, and its denominator degrees of freedom are 6, because how we got this test statistic, remember, was the mean square of this particular row divided by the mean square of error. Okay, so here we've got the degree of freedom in the numerator being 2, and the degree of freedom of the denominator actually being 6. Okay, so here the F distribution with 2 degrees of freedom in the numerator and 6 degrees of freedom in the denominator. All ANOVA tests are upper-tailed, so you can use the greater than sign. And then we can put in what the test statistic is. So I could put in the test statistic, and then here, finding out what that p-value is. I could do that in R just by saying I'm going to find the upper tail of an F distribution. So here, P of F gives you the lower tail, so 1 minus P of F is going to give you the upper tail of of the test statistic, where the degree of freedom was 2 in the numerator and the degree of freedom it was 6 in the denominator, which will give you here, here's the p-value from the ANOVA table. This will also give you the same p-value, so you can throw that into WebWork as well. Okay, so when we're looking at this p-value for the columns and now this p-value that we just found for the rows, or if you're just looking at your ANOVA table, these two p-values, in this particular case, both of the p-values happen to be larger than 5% or 0.05, which is the level of significance here. So what that means is we're failing to reject null hypothesis here, which means that it seems like the means of all of these groups are actually quite similar to each other. So if the means are all the same as each other, does it appear that there's any particular bank that has more robberies? The answer is no, because the averages seem like they're the same for all of the banks. And when looking at the bank locations, does it seem like there's a location that has more robberies? Again, the answer is no, because its p-value was also particularly higher than 5%. If there was actually a difference, so if I did have a p-value that was small, or two p-values that was small, which, excuse me, where would you actually find those particular differences? So here you can also make this visual. So here, this visual has just been provided to you, so we didn't really need to do this in R, but if you wanted to learn how to reproduce these graphs that WebWork had given to you, I've got some code about how you can do that. Here, this particular code actually creates a PNG file, which is nice because it keeps the legend looking nice. However, you can also just run the code in R without having sorry. You can also run the code in R without having to make a picture file. But sometimes the annoying thing about that is when you look at it, you can see that the legend is so spread out, you can't really see it. So I've included some code if you wanted to make this picture look a little bit nicer. But either way, WebWork is giving you the picture itself here. So when it's asking, what is it asking here? It's asking, looking at the data, which combination appears to have the most stolen. So whether you look at either this interaction plot or this interaction plot, either of the interaction plots are going to give you the same information. I am looking for the largest overall point. So in this interaction point, you can see it's this guy here. It's a square, which means it's the suburban group. And here it's in the credit union. And here the highest point is a circle, which is the credit union, and it's in the suburban group. So the highest group from either of these plots is telling us that it's the credit union from suburban, which is the lowest. You can see here this square point, which is the savings group in the rural category. And here the lowest point, again, is the savings group in the rural category. So either of those plots that you look at, either of those interaction plots do give you the same information, that if you did actually have a small p-value, you could see where the changes actually were.